Hello. Multiplying two more polynomials together is a little more involved. And if you've ever heard the term FOIL in a mathematical context, that's what we're getting into here. So when it's a monomial times a polynomial, you can just distribute the monomial to every term of the polynomial. So you know how the distributive property of multiplication works. You take that negative 4ab and you multiply it by every single term, all three of those terms in the polynomial. Like that. Now maybe you can jump right from negative 4ab times 2a is negative 8a squared b. Great. If not, we'll take this step for now because it just shows you how we got to where we're going. So now you just multiply all the like terms together, right? A's times the a's and the b's times the b's and the constants times the constants. So it's what? Negative 8a squared b plus 12a squared b squared minus 20a cubed b. Is that what I said? Yeah. And that's as good as it gets. So none of those terms are like. When there's two different variables in it, you have to have the variables going to the same power to combine them. So they all have an a and a b in them, but this is a squared b and this is a squared b squared and this is a cubed b. So none of them are really matched. None of them are like terms. So resist the temptation to take it farther than you can. This is it. Technically, you could factor 4 out of it, but you don't have to. Well, you could factor a bunch of stuff out of that, but we're not there yet. Okay, so that's it. Just know when to leave it alone. All right, multiplying two binomials together takes a little more stuff. It's not just the distributive property. It is kind of, but it's like a new version of it. So if you had to do these are a binomial times a binomial. So we're going to do 2x plus 3 times x plus 4. So here's what you do. You take the 2x and you multiply it by x plus 4. And then you multiply the next term, 3, by x plus 4. So both of those things involve the distributive property. And then you add those two products that you just got together. So your book explains this 3 different ways, all of which are perfectly cool and valid and good. And if you learned this a different way than I'm about to explain it, honestly, I would keep that way. I'm certainly not going to mark it wrong. And really, they're all doing the same thing, just a different path to get there. So this is me being old-timey and just being like, to me, the FOIL method, which is what this is, which I'll explain in a second, is just a simple way to think about it. But really, it's no different than multiplying a 2-digit number times a 2-digit number. If you're going to do that with like long multiplication, you would end up doing a product, doing another product, and then adding those two things down. So it really is the same thing as what's happening here. All right, so this is called the FOIL method, and FOIL is an acronym. It means you do, so let me draw some indicating arrows. You multiply the first terms of both together. Outer means, well, it means outer, these terms, so the 2x and the 4. I is for inner, so those are the inner terms, so that's the 3 and the x. And then finally, L means last. So you do the 3 times the 4. First, outer, inner, last. Now the thing about this is if you do it in some other order, you're going to get the same thing, just in a different order. Right? So this is just like a way of saying we're just doing it the same way every time. So again, your book is going to explain it a different way. They explain this too. This is in the book. But first they do it a different way. So I won't and can't fault you for doing it a little bit of a different way than me because you're always getting to the same place. So it's basically, it's my washing machine. Everything has to get multiplied by everything else. So since there's 4 things you're going to have to multiply together. This is just a kind of standard order to do that in. Okay, so it's 2x times x plus 2x times 4 plus 3 times x plus 3 times 4. Right, so the distributive property distributes every term to every other term. Everything gets multiplied by everything else this way. Okay, so let's keep going. That's 2x squared plus 8x plus 6x plus 12. sorry, plus 3x. That I said 6, I meant 3. Right, I don't know where I got 6, so it's 3 times x. So it's 2x squared plus 8x plus 3x plus 12. And then what you'll find is you now look at those two middle terms, the oi, those are like terms. So you can add those together. And so finally you get 2x squared plus 11x plus 12. Once again, notice that it's written in our nice descending power order. Okay, make that a habit. We like to see them like that. Okay, so that's the FOIL method. We're going to do this a lot. You're going to do this many times. So if you need more of an explainer as to why it is this way, go in the book. I think you've maybe seen this before, and either way, I think you believe me. But let's practice. So ultimately, like, you're almost going to be able to do this with one step. So you're going to do 3x times x plus 3x times negative 4 plus 1 times x plus 1 times negative 4. Okay? First, outer, inner, last. So 3x times x plus 3x times negative 4 plus 1 times x plus 1 times negative 4. Okay, which is 3x squared minus 12x plus x minus 4. Like that, 3x squared minus 12x plus x minus 4. And then notice again, the two middle terms are like terms. So they combine into just negative 11x. And you should combine them, okay? When you multiply two binomials together, you still want to simplify it. You want it to be as simple as possible. Now, it's not that simple, but that's as good as it's going to get. Okay. Like I said, you're going to be doing a ton of these. So if it still seems a little funny, you'll get used to it. All right. So like this. Okay, it's a binomial times a trinomial. So you can't just use FOIL because there's more than 4 terms in here. But the idea is the same. You have to multiply every term by every other term. So here's how I do it. I start with the very first term, the 5x. And you go, okay, I'm going to do the 5x times this, and then I'm going to do the 5x times this, and then I'm going to do the 5x times this. So I take the first term in the first thing and multiply by every term in the second thing. And then I just go to the second term and I do the same thing. I go the 2 times the x squared, and then the 2 times the 3x, and my arrow chart's getting a little messy, and then the 2 times negative 1. So I do 5x times x squared plus 5x times 3x plus 5x times negative 1 plus 2 times x squared plus 2 times 3x plus 2 times negative 1. So you see what I mean? You hit everything. Now, if you did it a little bit some other way, you would get the same thing. It helps to have a method so that you know you're kind of doing it the same way every time, and that you know you are being thorough in getting every term. So like this final product thing is going to have 6 summands in it. Okay, so that's another way to write it. I do the 5x times the entire second thing, and I just use the distributive property. And then I do the 2 times the entire second thing, and just use the distributive property. Okay, and I sort of just skipped right to this. So 5x times x squared is 5x cubed. 5x times 3x is 15x squared. 5x times -1 is minus 5x. And then we have a plus a 2x squared plus a 6x minus a 2. So you see what I mean? Now there's 1, 2, 3, 4, 5, 6 summands in this polynomial, 6 terms. And now just combine whatever you can. It may be that you can't combine anything at all. That's fine. Is it that way? No. We can combine the 15x squared and the 2x squared. So that gives us a 17x squared. And we can combine the negative 5x and the 6x, which gives us just a positive 1x. And that's it. Okay, there you go. So we got a polynomial of degree 3, right, that had 4 different terms in it. But you don't really know what you're going to get with these. You get what you get. Okay, so whether another teacher taught it to you different, or you go in the book and do what they call like the vertical multiplication, or you just do my sort of modified FOIL method, you know, you should get the same thing as your neighbor no matter which way you're doing it. Okay, we might have to multiply more than 2 polynomials. We might have to do 3. And, you know, you just do what we've been doing. You just repeat it. So if you're going to do a times b times c, you can just do a times b and then times whatever you get by c. That's all this is saying. So you just multiply any 2 of them that look easy, usually just the first 2, and then whatever you get from that, just multiply that by the third. So it's nothing we haven't done. It's just you're going to have to do it maybe a couple times. For example, so you could FOIL this second, this third thing together now. I think it's simplest just to multiply the first 2 things. So just do 3x times 2x minus 3. And that gives you 6x squared minus 9x. So I'm not showing all the details here necessarily anymore, because we should kind of be able just to jump to it. So now we have 6x squared minus 9x times x plus 7. Now it's just FOIL. Now it's nothing we haven't done before. So it's going to be 6x squared times x plus 6x squared times 7 minus 9x times x minus 9x times 7. Okay, so I just did that in one step. So 6x cubed plus 42x squared minus 9x squared minus 63x. And now the middle terms combine. They won't always, because these are different kinds of binomials and stuff, but these ones do. So let's see, 42 minus 9 is 33. And that's as good as we're going to get it. 6x cubed plus 33x squared minus 63x. You kind of get the idea. When you start multiplying more and more polynomials together, you get something with stuff with higher degrees. It's got more factors of x in it. Okay, and then here's a fun example to wind us up here. Find a polynomial that represents the product of 3 consecutive integers. A little vague there, but remember what consecutive integers mean, like 9, 10, 11. So let's just start by making the first consecutive integer be x. So by the first, I mean the smallest. So if it's 9, 10, 11, if our first one is x, well, the next one is x plus 1, and the next one is x plus 2, right? It'd be like 9, 10, 11. Okay, so if x is our integer, it can be any one. The next 2 consecutive integers are x plus 1 and x plus 2, and we want the product of those 3 integers. So there it is. Now, we can't stop there because we said we want a polynomial. Even though this is actually technically a polynomial, it's in this factored form, and we want it to look like a polynomial. So we know how to do that, just multiply all the stuff together. So again, I'm going to do the first 2 factors first. So x times x plus 1 is x squared plus x. Okay, so I did the first 2. That's generally just go left or right. There's no real reason to do it some other way, unless you just feel like it, and as long as you do it right, you'll still be right. So now we have to FOIL. So it's x cubed plus 2x squared plus x squared plus 2x. Right? X cubed plus 2x squared plus another x squared plus 2x. So that's just FOIL. And then once again, we see that we can combine the two middle terms. So it's x cubed plus 3x squared plus 2x. And that's as good as it gets. Okay, so this isn't like that easy. This is the most hardcore algebra we've had to do yet in this course. And I think this is probably the most challenging stuff. And that's fine. So if this seems like a lot of algebra or whatever, it kind of is compared to the stuff we've been doing. So for something like this, you can check and see that that just worked. So for example, if our x was 5, I'm telling you that this thing represents 5 times 6 times 7. And check that it does. Check that 5 times 6 times 7 is the same thing as 5 cubed plus 3 times 5 squared plus 2 times 5. It is. Do the same thing with 9, 10, 11. Do the same thing with 100 times 101 times 102. You're going to see that those two things are exactly equal. So 5 times 6 times 7 is the same thing as 5 cubed plus 3 times 5 squared plus 2 times 5. We just built that up and we showed it. Okay? Thank you.